Let us look at Fourier series in more detail. A function f of x is said to be periodic if it is defined for x in real numbers and there is a positive integer t such that f of x plus t is equal to f of x. So what does that mean? It means let's take f of x equal to sine x. If we take a point A anywhere on this function and let's draw a horizontal line passing through A parallel to the x-axis, then the function will intersect with this horizontal line at equal distances. Okay, similarly, we also know cos x. Again, let's take a point D. Let's draw a line parallel to the x-axis and let's take the intersection. Of course, there are other, since it is periodic, it will intersect in other places also at equal distances. But I'm showing only these three. So here, if I move this, you see E and F are at equal distances at any point. And same is the case with the sine function. Now, t is called the period of the function f of x. If t is the period, then 2 times t, 3 times t, or any multiple of t are also periods of the function. So f of x plus n times t is equal to f of x for all x in real numbers and for all n in integers. So the graph in the interval 0 to t repeats in every other interval. So if we take it here on 0, then 0, we can say 2 pi is t, 4 pi is t, minus 2 pi is t. For example, sin theta, cos theta are periodic functions with period of 2 pi, which means sin theta plus 2 pi is equal to sin theta, cos theta plus 2 pi is equal to cos theta. Like this, there are many such periodic functions. Now, suppose we have two functions f of x and g of x with period t. Here itself we have such two functions, sine and cos. H of x be equal to a times f of x plus t plus b times g of x plus t. Then this can be written as h of x is equal to a times f of x plus b times g of x, because f of x is equal to f of x plus t and b of gx is equal to b times g of x plus t. So which means h of x equal to h of x. So here it may look, a silly kind of statements, but the point is, if you have periodic functions, a function can be written as a combination of those two functions, periodic functions. So the left hand side and right hand side will converge. Now, single valued functions, which are most of them, can be expressed using sine and cos. And the Fourier series does exactly that. So you have f of x equal to a naught by 2 plus sum as n goes from 1 to infinity of a n times cos nx plus sum as n goes from 1 to infinity of bn times sine nx, where n is a natural number. Now these series are called Fourier series. The above series converges at all points x to f of x. We will look at examples later. Periodic in an interval, it could be 2 pi, it could be any other period also. But since we are talking of sine and cos, we usually take it as 2 pi. Now that interval we can take any. We can take it from minus pi to pi. We can take it 0 to 2 pi. That is up to us. Later on, another mathematician, Dirichlet, came out with some conditions. The conditions are a function f of x defined on minus pi to pi closed interval can be expressed as Fourier series where n is a natural number and a naught, an and bn are real numbers if the following conditions are satisfied. And the conditions are f of x and its integral are finite and single valued. F of x has discontinuities finite in number. And finally, f of x has maxima and minima finite in number. Now here a not a and bn are called Fourier constants and has to be evaluated. We have to be aware of some required integrals. So let's look at these integrals that are required. Now, as we saw in the previous session, we required integrals in Fourier series to arrive at a naught, an and bn. And there are certain integrals that we need to be aware of. The integral of sine mx dx in the interval minus pi to pi is equal to 0. Again, integral from minus pi to pi of cos nx dx is also 0. Basically, remember in the previous session, we had seen that whatever be the value of m, the area under the curve in this interval will be 0. The area above the x-axis will cancel out with the area under the x-axis. And similarly, in case of cos nx dx integral from minus pi to pi, that will also be 0. Integral from minus pi to pi of sine mx times cos nx dx will be also 0. The product of signs. Integral from minus pi to pi of sine mx times sine nx dx is equal to 0 when m is not equal to n or either m or n is 0. Integral of sine mx times sine nx dx in the interval minus pi to pi is equal to pi when m is equal to n. Now let's look at this with respect to cos. Integral from minus pi to pi of cos mx times cos nx dx is equal to 0 where m is not equal to n. And integral from minus pi to pi of cos mx times cos nx dx is equal to pi when m is equal to n. Now, here in all these cases, you have to remember that m and n both are natural numbers. And x is naturally in the set of real numbers. Now, why natural numbers? Because remember, the Fourier series formula takes the sum from n equal to 1 to infinity. So that is why it is in natural numbers. So no negative numbers are allowed and neither is 0 as far as m and n are concerned. This was a little bit more depth coverage of Fourier series. Now, in the next session, we will look at an example of arriving at the Fourier series for f of x equal to x square, which we already saw in the previous session, but we didn't really work it out. I just gave you a demo. So that is what we'll do in the next session. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.